Drive down Main Street in your community. Take time to go through a new industrial office park. About 1 out of 2 low-rise buildings are metal buildings. Glass atriums, soft muted colors on metal fascia, brick and masonry sidewalls accented by metal ribbing. Architectural visions far removed from the forefathers of metal building construction. Much industry progress has been made by system manufacturers working together through the Metal Building Manufacturers Association. Founded in 1956 with 13 charter members, MBMA attacks a broad range of technical matters that cannot be handled by individual companies operating on their own. MBMA sponsors research on the behavior of metal building systems, reviews building codes, construction practices, and safety regulations, and compiles and publishes recommended design standards that will ensure the highest quality metal buildings. Construction is one of the association's standing committees. It is responsible for recommending proper erection procedures of metal building systems. This presentation is one of the association's educational tools. Each manufacturer has certain proprietary features that require different erection procedures for its own systems. However, there are certain aspects to the erection of a metal building that are common to all systems. These are presented here and are to be implemented in conjunction with proven individual techniques and sound engineering judgment. The primary structural system of a metal building system is the frame that supports the roof, walls, and all externally applied loads. Several different types of framing systems are used today. Aside from minor individual differences between manufacturers, these systems include single-span rigid frame, usually with tapered beams, tapered beam with Type 2 connections at the columns, continuous beam frame or post and beam, single-span and continuous trusses, and a lean-to system. These framing systems are used for a wide range of building applications. You will find metal building systems used for office buildings, retail stores, shopping centers, automobile showrooms, banks, factories, warehouses, and distribution centers, plus community structures like schools and recreational facilities. Some metal buildings may require special erection techniques because of their particular use. These include crane buildings, structures that integrate various construction materials with the metal building system, such as concrete, brick, stone, masonry, glass, and metal. And finally, multi-story buildings more than 2 stories in height. More applications are being designed with 3 and 4 floors as industry technology advances. A true metal building system is a sophisticated structure. All structural members work together to support each other. MBMA believes structural integrity is best achieved when the components are designed into an integrated system and fabricated by one manufacturer. Therefore, sound erection programs are needed so that the building customer receives the maximum benefits of systems construction. Planning and Safety, Sections 2 and 3. An expeditious and cost-effective steel erection program depends on advanced planning during the pre-construction stage. Each project site should be examined and evaluated prior to material delivery. Alternate solutions to deal with unique site conditions should be developed at this time. A well-planned, clean, and orderly job site will usually trim overall erection costs, create an atmosphere of safety, and offer a perception of professionalism and craftsmanship. Primary project site considerations should include site accessibility, its impact upon material delivery, shakeout and storage, and the mobilization of erection equipment. soil condition, as it may affect support equipment, water runoff, access to materials, and drying conditions. Utility and support services, availability and adaptability. Once the site is assessed, a preliminary erection sequence can be sketched out. Back-check events against known site conditions to verify them and to learn about any problem areas. Now that the erection job has been evaluated with respect to the actual physical site conditions, the size of the crew can be determined to do the project most efficiently. Start with a small crew to lay out structural members. Add more workers as required. The type and number of personnel needed for each phase of the erection process should be defined in detail. Careful consideration should be given to scheduling functions that require specialized skills or equipment operators. For example, structural steel erection is usually separate from sheeting and flashing skills. Generally speaking, a small 7,500 to 10,000 square foot building can be erected with one crane and its operator and a 5-man crew, consisting of a working foreman, 2 lead men, and 2 assist men. Buildings over 10,000 square feet usually will require 2 more men in the work crew. The size of the work crew has been determined. Next, consider the potential impact other construction operations will have on your plant and work. You may find it necessary to adjust your personnel and equipment plan daily to operate most efficiently. Now that a workable sequential erection timetable has been set, you can arrange for the tools and equipment needed to complete the building on schedule. To implement a cost-effective equipment program, review some of your critical planning considerations. Is the site ready for the delivery of material? For the unloading and shakeout of the primary structurals, secondary component bundles, and panel pallets? For the positioning of primary structurals so they can be erected in proper sequence? For subsequent bundle and pallet positioning? And finally, for pre-lift ground assembly operations. Don't overlook basic hand tools that are conveniently available. Having proper tools in sufficient numbers to get the job done right will pay large dividends. The erection crew will work faster, better, and more safely with the right equipment. Ultimately, the chances of having to do the work over again will be reduced. Hand tools and equipment must be maintained in serviceable condition. Maintenance functions should be recorded on the tool and equipment schedule. The Metal Building Manufacturers Association Construction Committee has published a recommended basic tool package for 5 to 7-man erection work crews. The list will help you assemble the necessary tools to meet the specific project requirements. Included in the publication are lists of the quantities and types of tools appropriate to the erection of a typical building system. If the steel erector is not furnishing the foundation work, it is extremely important that the dimensional accuracy of the concrete-steel interface be verified. Be sure to check all foundation dimensions, including overall size, elevation, level and squareness, anchor bolt placement, and projection. The surest and fastest way to verify these dimensions is with a steel tape and a transit. Acceptable tolerance is usually defined either by the building manufacturer or by a reference in the general specifications. The building manufacturer sets allowable deviations in accordance with the inherent degree of flexibility embodied by his product design. Customer specifications occasionally may set limits for both the concrete and the steel, in accordance with end-use requirements. Foundation level and elevation should be checked with a transit and reference to a permanent benchmark. Overall squareness can be verified with a transit or a metal tape. With the metal tape, a 3-4-5 triangle method or a diagonal check method may be used. Overall, out-to-out of concrete dimensions and anchor bolt locations should be checked with a metal tape. Bolt locations should not deviate by more than 1/8 inch from the given center line of the column references, or by 1/4 inch in any 100-foot run. About 3 to 5 pounds of pressure should be placed in tape. Note that steel tapes are usually calibrated at 60 degrees Fahrenheit and may gain or lose 1/8 inch for each 15-degree Fahrenheit variation above or below this calibration point. Check each dimension shown on the building manufacturer's anchor bolt plan. This includes gauge, backset, and projection, as well as the major grid dimensions. Minor anchor bolt misalignments can be taken up by shifting the columns within the limits of the oversized holes routinely fabricated into the column base plates. In case of major misalignments, contact your manufacturing representative for recommended corrective action. The dimensional accuracy of the foundation and its anchorage points must be verified prior to any attempt to erect the steel superstructure. The precision defined by the tolerance limits is critical to the proper fit-up and subsequent synergistic performance of the system's components. While performing these dimensional checks, it's a good idea to clean the bolt threads, smooth the bearing surfaces, and mark the column numbers on the pier. Doing this in advance will save time and money once the steel arrives at the site. The Metal Building Manufacturers Association strongly feels that the most important single factor in avoiding the pain, suffering, and expense inherent in erection accidents is to develop a safe worker attitude each individual. The Construction Committee has published a construction site safety information booklet. It contains a number of field practices specifically aimed at encouraging the safe worker attitudes within all field personnel. There's no substitute for a committed safety program specifically tailored to project requirements and geographic conditions. All applicable federal, state, and local safety statutes, ordinances, codes, and regulations should be observed, including OSHA stipulations, and any applicable local, national, or international union rules, customary practices, or requirements. Material receipt, Section 4. When fabrication is complete, all building components are thoroughly inspected. They are carefully bundled and crated to prevent damage during shipment. The manufacturer will notify the builder in writing when a loaded unit is ready to be shipped to the job site. The notification should include the job number, routing, type of unit, unit number, itemized weights, total weight of the unit, and the date of departure. Care should be taken not to schedule erection crews and equipment until the builder is certain of the quantity and delivery date of the material. The auditing of materials is extremely important. The builder should verify the materials in the shipment against those listed on the shipping documents. A bill of material accompanies each unit shipped with all items included on the respective unit so marked. Package tags should be kept for later verification if necessary. If damaged material is discovered during unloading, make a descriptive notation on the shipping papers. Have the carrier sign them. Failure to note damage on the shipping papers will indicate the materials were received in a satisfactory condition. If there is concealed damage,